Hello and welcome. In this example, I want to talk about C pointers. C programming language has this thing called pointers, and you might have some understanding of it. It can get messy. So this is a little tutorial to have better understanding about what C pointers are and how they work. Let's say I have an integer star or integer x here. So this is normal, creating an integer. So an integer takes up 4 bytes of memory. This depends on the compiler, but in this case, it's 4 bytes. A double will take up 8 bytes of memory. And so this is kind of like a visualization of 1 byte, 2 byte, 3 bytes, and the first byte here of the integer, and I have 1. And here in this case, I have y equals 6, so I'm storing here 6. This is somewhat, to help understand how it would look like in memory. I can print the size of x, and this will give me 4. Size of y, this will give me 8. I can also print the size taken by a certain data type, including my own user-defined type here, which takes up a character take 1 byte, so this will take up 100 bytes, and a double takes up 80 byte, so this is 180. I use this to make sure it gives me exactly 180, because sometimes it takes up more because compilers do what we call optimization, stuff like that. So I don't want to get into that. But just to make it easy to understand, this will take up 180. As you can see here, for x, 8 byte for y, and then the size of each one of these. Long double is 16 byte data type. Float is a 4 byte data type, and so on. And now we talk about the pointers. So integer star is a pointer type to an integer. Double star is a pointer type to double. And what it is, it points to the first block of where an integer is in the memory. And so remember, when we created integer x, we have these memory blocks, 4 bytes. So and x points to the first block of that variable in the memory. With double star yptr, this will point to this block here, which is the first block of the value double. And if I print the two addresses, because I created them right after one another, the address of y is probably 4 blocks right after x. And so over here, I'm printing the address of x and the address of y. They should be next to each other. As we can see, this is the address for 4, and this is the address for 8. This is the first block of the y, which is double, and this is the first block of x, which is integer. However, the size of each pointer type is the same. The size will be 8 bytes because this is a 64-bit operating system. As you can see, this takes up 64 bits because that's how much I need to index my memory, to index in the system. So a 64-bit system, if I have the size of a pointer type, it will always be 8 bytes. If this was a 32-bit system, the size of pointer types will be 4 bytes. And voila, it gives me 8. Regardless, even my own data type would give me 8 bytes. Like even pointer to this type struct will also be 8 bytes. If this was a 16-bit operating system or a system, basically architecture, like Arduino, if you ever work with Arduino, that will take 2 bytes. And if it was a 1 byte, if it was an 8-bit system, then the address is 1 byte of size. Moving on to something interesting that get messy, pointer arithmetic. So if I say xptr equal xptr plus 1, I'm moving that pointer by size of int. So size of int is 4, so I'm moving it by 4. xptr now points to, interestingly, the first block of y, because they're right next to each other. And so if I print that, it will be the address we had for y, which is this address right here. And if I actually try to get the value, I will get 6. As we can see here, this is the address. Similarly with y PTR, if I do +1, this will move it by size of double, we'll move it by 8. And so we will move from this address here by 8, should give me 50 because it's 8, 9, and then A, B, C, D, E, F, and then 0, and then 50, basically. So this is the new address. So with that, it moves by whatever size double is, and double is 8. And now let's talk about a character pointer. Since character has size 1, this moves the pointer by only 1 block. So if I say cast the pointer to the first block of integer as a char star and then move it by 1, CPTR now points to, by this line, points to this block. And if I change it and put 1, this is what happens in the memory. It becomes 1 here. And if I try to print x now, what should I get? Well, this 1 here, if you remember, this is the 8-bit. This is 256 plus 1. This should give me 257. And there you have it. So this is help you understand how pointers work in the C programming language. Thank you very much.